That was unexpected. Uh, share my screen. Okay, okay. Start broadcast. All right, hello guys. So today we will be looking at the problems for linear function, right? So as for the homework, we had question 3, 4, 5, 8, right? So for today's lesson, we're gonna cover 3, 4, 8, 9, 10, 11, and possibly introduce some
Wait, we
methods.
had to do questions 9, 8, 11?
No, that's the problems I'm gonna do today. So it's
okay, because I didn't print out. I
yeah,
only
yeah,
printed
yeah,
out
it's
2 pages.
yeah, it was in the homework, but and then possibly looking at some elementary but pretty critical methods to analyze a linear function. What? Can you guys still see my screen now? Right.
Yeah.
Yeah.
So and then talk about the special line y equals to x and the intercept, and then as well as a very very advanced concept that which is like often applied in the IMO. It's called finite difference. It's not gonna be really hard. It's really simple actually. I'm just talking about the basic IMO.
IMO.
Oh, it's
What's that?
it stands for International Math Olympiad. Is where like the competition you see like those like bunch of representative of a country.
Yeah.
And they go to competition. Yeah.
Like all around the world, I think.
Yeah. So yeah. Finite difference is yeah, it's a very advanced technique. However, the concept is rather simple. Yeah. All right. So
Wait, how do you know this? Did you go do like it?
no, like, of course no, man. For sure, no. I know it because I do the problem. Like, I don't do the problems. It's too hard. I do something that's of course simpler than that. But yeah, it's a very good technique. All right. So first, question 3: the vertices of a right triangle -3, 4, -3, -4, 7, -4. Explain why the point 2.0 lies on the side of the triangle. Anyone solve this?
I did.
Okay.
I also did, but I don't think I got it correct. Because, like, I don't
Okay.
know if I got it correct.
Yeah, I mean, some of you might have. I haven't checked all the homework. Sorry. So yeah. So basically, what this is gonna look like is that we're gonna start a new page. Question 3. This question is actually pretty interesting. 3. We're gonna draw the Cartesian coordinate first, like that. Right, -3, -3, 4, -3, -4. Alright, sorry. -3, 1, 2, 3, 4. Okay, here's the point. -3, 4. Alright, just a random question. If it's -3, -4, how would you describe the transformation from, say, this point A to point B? Right. I'm just gonna label it. Point A is -3, 4. B is -3, -4. How would you use a mathematical expression to describe the process that you transform A to B?
You translate A 4 units down.
That's one way to do it, but there's more obvious and concise way. Another sort of. All right. So, what are some types of transformation first? Yeah, I'm just saying.
Translation, rotation, reflection.
Yeah, transformation. Translation, right? What is a translation, Alan? Do you mind telling us what that is?
It's keeping the same shape or point, but you're just like moving it around.
Yeah, it's kind of like. All right, so there is two components. All right, so when I'm talking about transformation, it's basically referring to the function of a function. Like, it doesn't have to be like only limited to the conversation of linear function or whatever. It can be to like anything. It can be to like the floor function, not really that, but it can to be like referred to the like absolute values and something like that as well. Transformation of the function. Translation. All right, translation. What are two directions for a possible translation?
You move down or like you move up and down or side to side.
Yes.
First off, what is a translation?
All right. So yeah. So I'm gonna do that real quick. Sorry about that. Translation is basically like, say you have a is pretty much what Alan has suggested. It's just like keeping the same shape, but you're moving around with it. In general terms, it's just like moving without changing anything. All right, so I'm gonna do a concrete example here.
How
You
can you
say
move without changing anything?
you have a dog right here, right? Let's name this dog Michael. Let's name this dog Michael. All right. So what are some possible like translation? And say that you have a square containing that. What are some possible translation? You can move Michael to here, right? But then the size. Notice that we can call this as A. This is B. A and B have the same shape. That's how you kind of understand it and approach it in more general terms. Right? So like, can you move Michael to here with a rope? Sure. Right? Just have a rope right here, and then get this to Michael's neck, and then you move Michael to here.
You're gonna kill it, no?
Right. You
Butcher it. Butcher it for dog meat.
Do you see how this works? Alright. You have the same Michael, but you're just moving Michael around. You can move Michael to anywhere. Oh, what? You cannot do the hello thing. Why?
So I can move Michael to the butcher, and then the
Sure.
butcher can
Yeah.
like kill Michael.
Yeah. Say
You
that.
want to kill a dog? No.
All right. Say
If
that.
Michael was like a wild dog. Like,
Michael's pretty
like-
wild, actually.
what?
Hey, so here's a store, eh? We established this store on the Cartesian coordinate as well. When you translate Michael to the store, notice that this is also a 2D like dimension. You have Michael here, right? And Michael doesn't change, right? It's not. It's kind of like you move Michael to the store, but the size of Michael doesn't change, right? There's no like Michael gets thinner, Michael gets fatter, like, right? Michael doesn't change, right? So that's basically the idea of translation. You're just moving a figure or a graph, sort of like that, like a function. Like say, I'm gonna do some example that's more mathematically related. Yeah. Whatever. So here's a graph, say. Here's a graph. Like that. What I'm gonna do with it? Okay. Sorry.
You move the stick with it.
The plane, yeah. That's the axis. Like that. Say that's a graph of function gx. And that's what happened is translation. You move gx here, 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 as long as it doesn't change. I mean the shape. Or it doesn't shrink or expand. Do you guys kind of like the formation doesn't change? Do you guys kind of see what I mean by translation? I know. All right. That's a very basic concept. If you guys don't get it, then just speak. All right. However, if I do this, resize. Right? If I do this, then this is not translation. Oh, we would say this is still translation, but the process is not only translation. Do you guys kind of see what I mean? Translation basically describes.
So
it
translation just like a graph, and then it's moving, but you're not changing any of its qualities, right?
Yeah, for sure, for sure. Yeah, that's the concept involved with translation. Okay, I'm gonna label that. The formation doesn't change. You are just moving it around. Alright. That makes sense, right? What are some I mean what are the two directions involved with translation?
Up and down and left and right.
Alright, so in mathematical term we call this horizontal translation and vertical translation. So as for vertical translation, it's of course refer to moving it up and down, right? Horizontal is horizontal.
Is side to side. Vertical is up and down.
Yeah, that's what I said. Vertical is up and down.
Okay.
Horizontal is alright. I'm gonna put this in like a more rigorous way. What it means by horizontal is parallel to the axis, parallel to the y-axis. Those are actually called the reference axis as well. So I'm gonna do some. I'm gonna do a concrete example. So like here, if you do it like this, say that's a plane, right? Say for example, that's a plane. Then what is defined as a horizontal direction is a line
A parallel to the x-axis.
Yeah, yes, sir. It's not really parallel. Yes, sir. Like here, eh? So that is the
Yeah.
that
If
is
that
the
is the
that is the line parallel to the x-axis. So everything is basically established on a relative concept. There's no like absolute horizontal vertical. You know, like you gotta have a reference point. In this case, well, normally it looks like this, but when you talk about horizontal translation, a vertical translation, more rigorously, it's the line parallel to the x-axis and the y-axis as the direction, right? So that's for translation. And for today, the other transformation I'm gonna shed some light on is probably reflection. There's a ton, like there's tons of them. There's like expansion, like shrink, like whatever. Reflection. Do you guys want me to start another page or just it'll be fine to put some notes on? I'll start another page. Actually, yeah, I'll start. Oh God. Reflection. Reflection has a similar idea. Alright, so what is reflection basically? Can someone tell me what is reflection?
what it sounds like. It's reflecting something. It's reflecting something again. Reflecting a function against something. Like it can be reflecting against a line.
Alright, so at this point we will just generally talk about reflection over a line, okay? Reflection over a reference line. For example, quick demo. I'm gonna switch this in black actually. Here's a line. Here is a line. Huh? What happened? What? Oh yeah, here's a line. What will be the reflection over the x-axis? All right, three options. First option is this. Is this. Second option is whatever this. Third option is this. Sorry. Option 1. Option 2. I know it's kind of stupid, but we still have to do option 3. Which option do you guys think is the case?
It is the option.
I can't see.
Oh, you guys cannot see it?
Now we can.
Now I can.
It is
Option
in 3.
it's the, yeah, 3.
Yeah. Alright, reflection of the.
We're so smart.
Yes, sir. I know it. Blue
Damn,
line over the x-axis. You always gotta have, you know, the thing. You always gotta have a reference line. Oh, I spelled this wrong. Axis, not axis. Reflection of the blue line over the x-axis. This is the option 3, right? What about for the y-axis?
It'd be the exact same line, but it's longer on the it's longer on the
We have the option here. Choose the option.
reflecting against the y-axis.
Yeah.
There is no option.
None, like the original blue line.
Yes, sir. It's the option 1. It's kind of like a mirror, right? You reflect this part to this part to that.
Wait, but it has to be on the
Wait,
same.
which one is it? Which one is it?
It's option 1.
Why?
Wait, what? That's not. It's not right because you have to make option 1 like go down a bit.
Yeah. Parallel, I mean,
Oh yeah. I mean, yeah. I mean the graphs, right? I mean, it has to be like that. It has to be collinear to this line. That's what I mean. Sorry.
Oh yeah.
Because like I cannot draw the same. Sorry about that.
Yeah.
Reflection.
Okay.
Sorry for this vagueness. I shall repent for that reflection.
and, if you reflect over the y-axis, I mean, for a line, I think it's itself because horizontal line, and if you reflect it, it's still the same thing.
Notice that this does not actually continue.
Oh, okay.
Yeah. It's a good point. No. Over the y-axis. It's option 1. No. Notice that this has to be collinear, meaning that it's on the same line. Sorry for this. All right. So pretty much, right? We have the sufficient knowledge to do this right now. All right. So in terms of -3, 4, -3, -4, what is? All right. So give me the translation and the reflection. I'm just gonna call on the new member here, Steven and Tim. Hello, Steven. How you doing, buddy?
Hi.
Hello, are you there, Steven? My internet is lagging. Okay, no problem. Hello, Tim. Is your internet lagging as well?
Damn, lots of people's internet are lagging these days. Wasn't your internet also lagging?
No, he didn't have internet.
Okay.
Oh, I thought his internet. Oh, yeah. Okay, okay.
Alright, so what about Matthew and Ryan? Do you guys want to try?
Huh?
Yeah. So in terms of translation, what happened from A to B?
Well, what you did was you moved it down 8.
Yes, sir. So you say it's a vertical translation of -8, pretty much. Right? Nice, nice. Ryan, how would you describe that? This transformation in terms of reflection. Is Ryan here? Alright, Alan, describe what happened with
It says he's
reflection.
disconnected.
Oh, he's disconnected?
No, I don't think I don't think he's disconnected because I think it's like you can hear, but you can like you go kind of boot. I think I don't.
Why he says that, but anyways, he just reflected across the x-axis.
Yeah. So A is basically reflected across the x-axis. Correct. Alright, so we're actually gonna speed up a little bit. 7, -4. 7, -4. 7, -4. 7. 7, -4. Explain why the point 20. Where's 20? Here, right? 20. Explain why this. Oh, what? Okay. 20. Explain why 20 lies on the line.
Because wait, am I explaining it?
Hello, I came back from the washroom. Okay, you can just permanently stay in there.
Lol.
You can just stay in it.
Who said
For
that,
life.
Tim?
What do you mean?
You can stay in the washroom for life, probably.
Tim, you stay in the washroom and practice for like 30 minutes.
Oh, yeah, I know. That's the place where Tim master his swimming, right?
Yeah, definitely.
Wait, damn, did everyone hear some?
That's simply. Alright. Alright. So basically, we denote this point C. Sorry. C. B. Alright. We're trying to examine if S lies on the line segment AC. Alright. Before we actually get into it, why do you guys think it possibly works? What are
Because
some reasons for it to work? All right,
If
continue,
you
John.
you can see it looks about on T0.
All right, I think John was trying to speak.
I mean, it looks very, very alike, and it only can be on AC and not AB or BC.
All right, so here's the question. It doesn't mention that. All right, Matthew, do you want to speak?
Never mind. You can go.
Okay, so it didn't say that it has to lie on one of the side, right? So it can just be like
It
not.
says Y. It says Y does a lie on the
Oh,
side.
why? Sorry. Well, yeah, sure. I mean,
Isn't it because it's like one of the x intercepts of A and C? I don't know. That
that's
was
an
what I said.
interesting question.
Even know the function for ATC yet, so you can't just say that.
Oh, do you guys know anything about like midpoint like that?
Oh,
Okay,
yeah.
okay. So here's
Huh?
thing.
Huh?
Oh, hello.
What did you say?
I said, do you guys know anything about midpoint?
Mid play?
Yeah.
No.
No. Okay. Okay. So here. Oh yeah. I'm actually gonna change my teaching schedule today. I was gonna like go further of all the questions, but I just realized that's a midpoint actually. I just followed it. Why do you guys think this is the midpoint?
Oh.
Why do you guys
Okay.
think 2-0 is the midpoint from -3, 4? All right, I might rephrase it actually.
Um,
I'm just thinking of if this is
um,
the midpoint, what would be the property of a midpoint? Like, how do you know 2-0? Like, I'm just kind of giving the answer. I want you to explain it. Why is 2-0 the midpoint from -3, 4 to 7, -4? Not by not just by observation. Oh yeah,
Negative
because
3 plus 7 divided by 2 is 2. I mean, is 2, and negative 4 plus 4 divided by 2 is 0.
-4 divided by 4.
Negative 4
I
plus 4. Plus 4 divided by 2 is 0.
Okay, what was the first thing you said? Like -3 plus 7 divided by
Yeah.
2.
Yeah.
Okay, so here we kind of touch on the definition of what a midpoint is. Just
could
kind
I
of like wait, are you speaking, Matthew?
could I
Oh,
explain?
Alan. Sure, Alan.
So from -3 to 7, that's 10 numbers, I suppose.
Yeah,
And if you divide 10 by 2, that's 5, and
yeah.
which is half. So -3 plus 5, or you can say like 7 minus 5 is 2, which is, and that is right now we're talking about the x. So 2 is the midpoint of -3 and 7. And then for the y, it's 4 and -4. Between that, there's 8 numbers. 8 numbers divided by 2 is 4. So if you like -4 plus 4 or 4 minus 4, it equals 0. So that's why it's the midpoint.
Okay. Yes, sir. Yes, sir.
Could you say that again?
Do you mean me or Alan?
I don't really care who does it.
All right, Alan. Do you want to explain it again so I can go grab my water?
Yeah, I'm sure. So between -3 and 7, there's 10 numbers. And if you divide 10 by 2, because you want the midpoint, mid is like half. So if you divide 10 by 2, it equals 5. If -3 plus, either -3 plus 5 or 7 minus 5 equals 2. and that is right now the x. We're talking about the x like axis thing. So
Okay.
right now for x, that is the midpoint. 2 is the midpoint of -3 and 7. And then for the y-axis, 4 to -4, that's 8 numbers. 8 numbers divided by 2 is 4. If you -4 from 4, or you +4 to -4, it equals 0. So 2, 0 is the midpoint of of 7 and -4 and -3 and 4.
Yeah, that's actually a very nice explanation. I'm gonna go kind of introduce you guys with the concept of midpoint. It won't be too hard. And I would say the principle behind it is just similar triangle. You guys haven't touched on it, but just kind of conceptualize it. You will understand it better in the future. Midpoint. Oh yeah, I found what we were going to talk about today. I was actually kind of confused about what to teach. All right, midpoint. That's a very nice thing. Midpoint. All right, we're gonna look at it in a progression. First, as a parallel line. Second, as a a line that is not so parallel. What it means by a parallel line. So here I'm gonna draw that first. This is gonna be easy as hell, I swear to God. This part is easy. You won't mess it up. Alright, so here's the plane. Let's say -4, 2. 4, 2. Tell me what is the midpoint. Tim, what is the midpoint for this? Hello, Tim. Are you still in the washroom? Tim is swimming.
Wait, he's swimming?
Yeah,
Wait,
Tim is
what?
swimming
He's
in the
swimming,
washroom.
but
What was it?
who, me?
Oh no, I was talking about Tim. I was saying Tim is swimming in the washroom. Anyway, all right. Anyone else?
How do you swim in the washroom?
All right, Tim. Oh, Tim is back.
How do you swim in the washroom?
Tim, what is the midpoint between -4, 2 and 4, 2? Simply.
A 0?
Midpoint. It's a coordinate. It's not just a point.
Okay. Isn't it 0 too?
Yes, sir. 0, 2, right? Easy, right? Easy money. 0, 2. How so?
Because they're all on the same y coordinate, and then the midpoint of 4 and -4 is 0 on the y coordinate. On the x coordinate, -4 and 4's midpoint 0. On the y coordinate, they're all the same.
Do you guys know about absolute values and that?
Yeah.
No.
Yeah,
I'm just do a quick survey. Type
isn't
one
it?
in the
Oh wait,
type one in the class A chat if you know what absolute value is. Please.
dang, only 2 people know.
Wait, what? Can you like give an example of absolute value? I might know it. I might not.
Absolute value of -1 is 1.
Oh, absolute value. Yeah, yeah.
Oh, is it where like even? Oh, is it like
Isn't there
where?
like the two? Yeah, isn't the like the two bars on the
Yeah,
side?
like the
Yeah,
two
it's
bars
the
on
two
the
bars.
side and then like 2 bars and a -1, and there's like 2 bars around that,
So
and then
whatever
it
is
equals 1.
inside, whatever it equivalents to, it's equivalent to the thing, but then non-negative.
Like
So
it's only positive. There's no
yeah,
negatives.
even
Right.
the answer from an equation or something.
Yeah, so if there's like 2 times absolute value of -2, then there'll be 2 times 2, which is 4, right?
Yes.
Yeah.
No, actually, it's isn't sometimes like some equations depends on negative and positive, and the answer is different.
Well, like the
Again?
Wait,
The what?
so
I didn't hear that. Sorry.
isn't it like -2? Like for example, -2 minus 2, and then in the equation you can't make -2 a positive. It has to be -2 minus 2, which is equivalent to -4, and then you make the 4 positive.
All right. So I'm gonna do a second survey. What is the meaning of that? Say A minus B. Like I'm just trying to like absolute value of A minus B. What does this mean on a?
Is A bigger or B bigger?
It doesn't matter. What is the
It
meaning
means A minus B.
on the line when you say absolute value of A minus B?
It's A minus B.
It
Okay.
either equals A minus B or B
Or
minus
B
A.
minus A. Yeah. Depends on which one's bigger. If A is bigger, it's A minus B. If B is bigger, it's B minus A.
Not quite actually.
For the answer though, isn't it just all? And if A is a negative number, is
Well,
A plus B?
putting it into this way, right?
What do
If
you
it's
mean?
just simply a sign to kind of say like if A is greater than B, then it's A minus B. If not, then it's B minus A, vice versa. Then it doesn't really have, you know, a meaning to actually exist in this mathematical world. I like to my conceptualization, a thing exists because there's often the general interpretation and like otherwise there is also kind of like the other interpretation that you don't really see it but it also makes intuitive sense in this way, right? So for example, I'm gonna just give some examples. Say y, you know how y equals to ax plus b, right? This is a function. This is a this is actually a equation. However, you also say fx equals to ax plus b, right? It's basically the same thing. It's on the surface, y is just fx. Then why do you design this fx? Have you ever thought about it? So one thing exists not because mathematicians are stupid and they just want to create like fancy stuff, they exist because they have other, there's just room for exploration, not just for the um, very basic interpretation. So when you say a minus b, the absolute value of this refers to the distance from a to b on a number line. For example, I'm gonna just give you some example. You will get it. Those are this is actually the basics behind this, behind the midpoint. I mean, like how to calculate the distance. All right. So, for example, 3 minus -5 is 8, right? Well, but when you actually put it onto the number line, you see how here is -3, right? -5. Here's 3, right? And this is 8. Well, you might say something like,
Okay, actually, doesn't that equal 2? Oh, wait, no. Yeah. Shouldn't that 3 minus -5 equals 2, right? Oh, wait, no, never mind. I thought that said -3.
fine, it's fine. So basically, you might just say something like, I can just basically subtract -5 from 3. Why would I need this absolute value? Absolute value is basically the thing that does it for you. It's kind of like when you say you're coding or something. You just want to like probably imagine math as a process of like doing coding or something. You don't have the like just capability to say this, to write this is the distance, but this expression just profoundly like represents what's happening. Yeah. So do you guys, does that kind of make sense? It's not like you're stating it by words. It's not like I'm writing on the paper, this is the distance because 3 is bigger than -5. So I might have to subtract -5 from 3. But absolute value just does it for you. If you put it on the paper, it just comes. The meaning just comes, and what comes along with it is some extension with how you manipulate this identity and sort of stuff. All right. So, all right, I'm gonna ask you a question. Is the distance from A to B the identical distance from B to A? Right?
Yes.
Is it? Yes, sir. Right. So when you like, that's just magic, right? When you have -5 minus 3, that gives you 8 as well, right? Vice versa. Let's kind of just how to say, let's kind of deduce it backwards. Where does the distance from A to B come from? How like this meaning is actually so strong. This statement is actually so overpowered. Where does this come from? Like distance from A to B. Like why does that even come from? Where does that even come from? You know that with absolute value, right? I'm just kind of like doing it backwards. I'm just kind of doing the deduction backwards. The logical progression backwards. You know that with the I'm gonna actually write some words right. It's not like that you just know the definition, but you kind of like know where the definition comes from. It's the distance from A to B. Right. I'm gonna write a side note there. All right. If you haven't been listening for the entire class, please listen to this part. This is very important. I would say this is the core. This is the essence of how you kind of like process a math problem or just math thinking. With absolute values, it enables you to reverse A and B. How to say? Reverse A and B. As because you are just basically manually finding the larger number. Identifying, obviously. I think that would be a better word. Identifying the larger number and the smaller number. I'll say without loss of generality. How to explain that? Say, for example, B is larger than A, then A minus B equals the B minus A. That's basically the process. However, with with the presence of the absolute value sign, it avoids the process of actually finding it. It automatically does it for you. So what this means, the ability right here, I will say the point right here, just to relate what does it mean to have the it basically what it does for you is just to have the bigger point and you subtract it. You subtract the minor point from the bigger point, and you have to think about what this really means, right? If you really think about it on a number line sense, it just basically you're counting the distance from the because basically you're subtracting the smaller number from the bigger number. In this process, you're just finding the distance, right? And then vice versa, you cannot subtract like 3 from -5 or else you get a -8. However, distance has to be a positive number, right? So just kind of think about it. What this really means is that is there like a sort of connection with the absolute values? The ability here, like the point here is just to make connection. Make connection. Okay, I'm gonna point out the connection. Distance. Shoot. Distance must be positive. absolute value. Or I don't know what I'm saying. It's not positive. It's non-negative. We talked about the concept of like non-negative last session, right? Non-negative. Can you guys hear me right now? Can you guys hear me right now? I just want to confirm.
Yeah.
Okay. All right. That's good. That's good. It has to be non-negative, right? Just kind of the conclusion here doesn't really matter, but just the way you're thinking about it, just the way you're processing a math problem or just any problem that deals with logic. Because I think just from my personal experience, everything from math is essentially a process of making connection. The most complicated things are built from the most basics, the most like intuitive things, like just like A equals 1, B equals, like very, very basic things. But they were able to reach until the level that like seems so abstract and so hard to comprehend is mostly because they are strong in building a thread. Thread in the sense that you are able to connect everything. It's kind of like you're being a detective. You have all the clues. And some of the clues might just seem so minor. Like they don't matter. Like what? Like there's the dust, dust on the floor. What does this really represent? It represents nothing. But how is the detective, right? Sherlock Holmes able to connect all those like minor details and put them all together? This is where the math comes in. It's your ability to make connections. The most complicated stuff come from the most simple. So as for here, you notice that distance must be a non-negative. Absolute value must be a non-negative as well. Is there a connection? Alright, so here's the thing. Distance must be non-negative. Absolute value has to be non-negative. Second, distance from A to B is the same as B to A, right? Second point, absolute values. The absolute value of A minus B is the same as B minus A. The order doesn't matter. Does that imply anything? Question yourself. Question yourself. So, why coincidence? I think that's the essence about math as well. Why this coincidence? Why, when you try to explore a problem, why does this look like there is a connection? Why does it look so familiar? Question yourself. Is that really a coincidence? All right.
Yeah.
Questions?
Oh, no question.
Okay. How do you guys find this? Like the thing I was just talking about. Do you guys think this is like, do you guys kind of understand what I'm talking about? Or no?
Mhm.
Yeah.
Yeah, I understand.
Yeah.
Doesn't
So,
it's not exactly that like difficult in my opinion.
but you guys kind of see how this conclusion comes from, right?
Yeah.
All right. So it's basically you have the distance, and you notice that distance must be non-negative, and absolute value must be a non-negative value as well. And distance from A to B is the same as B to A, whereas order doesn't matter. And this applies the same in absolute value. So you got to question yourself, is there a connection between the word distance and absolute value? And you just discover that the absolute value of A to B is the identical thing as, distance from A to B. That's it. Simple. Not simple. The math here, the conclusion here is not complicated. But the idea here, like the idea how you kind of make this sort of connection is very critical in a analysis process, right? Like maybe just 10 years from now, those conclusions, you might forget everything about math. You don't remember anything, but the way you process this thinking is very essential and will be very beneficial for the rest of your life. All right, so yeah, all right, let's continue. All right, so simply, the midpoint between negative 4 and 2, negative 4, 2, and 4, 2 is 0, 2, right? Simple. And that is when we were talking about the midpoint on a line that is parallel. In other words, they all have the same y coordinate. They all have the same y component. So this way, this line is parallel to the x-axis, right? So it's just simple. You just do whatever. You just add up this. All right. So basically, if you notice that, I'm gonna give you some. Do you guys want me to erase that, or you guys want to keep that? The Michael thing.
I don't know. You can erase it, I guess.
Okay, I can erase it. Michael would probably be mad if he sees it. I don't know him.
And keep a small Michael in the corner, I suppose.
Okay, so all right. So I'm gonna put this midpoint. Why I talk about absolute value is the midpoint is precisely describing the distance. How to word this, how to phrase this. Point. Alright, half of the distance. How about this? Half of the distance. For example, we have point A, Y. Point B, Y. Y is a constant. I'm gonna put K actually. My Y might seem kind of confusing, you know. AK, BK. Right, here's AK, here's BK. This means it has the same Y component, which means the line is parallel to the x-axis. So it's a similar idea as 1. Okay. Now, what is how do you identify the point? How do you identify the midpoint on the Cartesian coordinate? Midpoint.
For the x coordinate, it will be a plus b divided by 2.
Wait, can't you use absolute value and then like a minus
Yeah.
b, so
Yeah,
that that's the total distance, and then
kinda
divide
want
that
you
by
to-
2.
I kind of want you to use that for that.
Okay.
Since you have to, in order to reach this midpoint, you have to like say here's the total distance, right? Here is the total distance, right? You cut it in half, right? Like this is half. This is not exactly half, but it is half actually. You cut it in half, and you get there, right?
Yep. Except, oh yeah.
So how would you describe it? Using absolute value. You using something we just learned.
The absolute value of a minus b divided by 2.
Okay, how do you combine this with the basic coordinate in order to form this coordinate? Yeah. In terms of distance, half of the distance, this is definitely right, but how do you further like here's like xy. What exactly is xy? Y is k, right? What is x?
The absolute value of a minus b and divide by 2.
That's it?
Isn't there like you? Wait, my mind just went blank. Wait, what?
That's it?
I think so.
Alright, so okay. So let's assume this is the right way to put it in. When you have this, right? -4 and 4. No. Sorry, I mean A is -4, 2, right? So here's K. B is 4, 2, right? As the way you have suggested, A minus B, what is this? What
Wait,
is
isn't it add a plus a? Oh no,
Yes,
minus a.
you have to plus A, right? Because
Yeah.
you are starting from A. You start from A, and then you plus half distance. Right?
Yep.
Alright, for this. Assume A is smaller than B. You start from A, and then you go to B. Right? Simple. In other words, this is how to say A plus A minus B. Okay. Here's the point. If B is greater than A, what does A minus B, the absolute value of A minus B, simplify into?
Wait, could you repeat that?
Alright. Now your task is to simplify A minus B. Absolute value of A minus B. Given that B is greater than A.
B minus A divided by 2.
Yes, sir. B minus A, right? Divided by 2. Then you have A plus B minus A. Okay. What does this give you?
A plus B divided by 2.
A plus B divided by 2. Okay, right? That's just kind of like one way to understand why this formula works. Do you kind of see what I mean, John? Like, you know the formula, but you might have to develop, like, it will be better to actually develop another way to approach it to explain why this works.
And also, it's like A plus B divided by 2. I think that's the like average. Find like the average thing.
Wait, how did you get to A plus B divided by 2?
Oh,
Wasn't we just at
because you
B
have
minus-
2A, right? You have 2A. So, like, B plus A, right? A plus B divided by 2 is.
Oh yeah. Oh yeah.
So,
yeah.
So think about it this way.
Oh, so you brought the A into the fraction. Yeah.
A plus B over 2 is the average. Is the average. That's the first sense. That's the first way to think of the problem. Second way is just more it's kind of like more approaching the core of those midpoint definition, because when you talk about midpoint, it's just saying that this point plus the smaller point plus half of the distance, right? So when you actually think about what is the half of the distance, you have the absolute value of A minus B divided by 2, right?
Yep.
Yeah. So that's the second way. What we are doing right now. Yeah. So like right now you have like two different approaches to understand this. Any question?
No.
All right. We have 15 minutes left. We spent 1 hour and 30 minutes going over one problem. That's insane. But that's pretty good actually. It's not like you're just solving the problem. You're learning something, right? Alright, so here's the thing. Okay, that's pretty much it. That's pretty much I mean that's pretty much how you do the first type of problem for midpoint as a parallel line. What you do is to add up.
I have a question though.
All right.
On that question, it's like just incidentally, 2-0 was the midpoint. But like, what if it wasn't the midpoint, but it was still on the line? Like for another question, you would have to use a different way, right?
Yes, the other way you will have to use it is construct the linear function.
Yeah, okay. Because I did that for this question, and I didn't realize there was an easier way. So
Yeah. I didn't realize that was the thing as well. No, I mean I didn't sort of, because like this course is supposed to be for I mean this handout is supposed to be designed for linear function, right? So like I just realized that actually.
I have I did it like differently. I didn't like remodel the function.
Alright, what did you do then?
I just calculated the slope like of the 0.20 and to the point -3,4, and then calculate the slope of the 0.7 -4 to -3 and 4. See, it just slopes are the same.
Yeah, this also works. This also works. No
Wait, I
problem.
couldn't really tell. Was he just constructing the function?
So basically, all right. So here's this line. He did it through a slope. So basically, slope is all right. I'm gonna do some. I'm gonna do. Do you guys want me to? All right. How about this? I will finish the midpoint thing first, and then we can go through what John has done for the problem. It's fairly interesting as well. All right. You just add up the two. X, horizontal component. Horizontal component divided by 2. Pretty much. Hey, here it goes for the second. Advance midpoint. Here's the thing. We call this x1, y1. We call this x2, y2. Now we claim the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So basically, what you're doing for a line that is not parallel to the plane is just that you have the vertical component, right? Half. And you have the horizontal component, right? Okay. Intercepts. Sorry. Intercepts. At this point. And this becomes the midpoint. Hello?
Okay.
Hello? Did you stop talking or did you cut out?
Yeah, I thought I just stopped talking or
Okay.
something.
Oh, no. Yeah, I just stopped talking.
Ah.
Now my question is, prove it. How to prove this? How to prove this? How to prove that when you locate this, the y component, on this slanted hypotenuse, how do you know it locates at exactly half of the line segment?
Because it was divided by 2.
Mathematically prove it.
Because the midpoint and the left bottom point and the midpoint, and then creates a triangle. Right triangle that is congruent to the triangle with the midpoint and like the point on the top right place.
I think you mean a similar triangle, actually.
Wait, so it's basically like the two endpoints of the line segment. You extend them until they meet at a point, and then it creates a right triangle. And then divide both sides by 2, and then extend that. And then when they meet, and then the point that they meet, it's the middle of the line segment.
I'm just basically saying that you have x2, y2, x1, y1, right? And y, when you take half of the distance, horizontal distance, you have here. And when you take half of the vertical distance, you get here. And then you just extend it and you intersect at a point. How do you know, like, why is that the midpoint of the hypotenuse? That's my question, pretty much.
Because the point is an extended point of both sides, like the half of both sides.
Like, mathematically prove it. As John has said, it pretty much proves it. So basically, but then it's a congruent triangle, yeah. So basically, I think we taught you guys congruent triangle, right?
Yeah, you did.
Yeah. It wasn't me, it was Alex, though. Alright. I'm gonna explain this. 2 ways, right? I'm gonna approach it 2 ways. Very interesting. Assume this is A. Assume the length of this is X. This is X. Right? If X is half, then what is this? Then what is this? Also X, right?
Yeah.
Then what is this part?
Also X.
Also X. Because it's basically parallel and it's a rectangle, right?
Yeah.
So X just goes
Yep.
here. Right? What about that? Let's say this part is Y. Distance, like half the distance is Y. Then what about that? This is Y, right? Y, right? What about this part?
What?
Y.
What?
Okay. Here's the angle, right? This angle is right triangle, right? Right angle, right? This is 90 degrees because this part is 90 degrees and it translates to this part. So this part is 90 degrees as well, right? And
Yep.
this
Yeah.
has to be 90 degrees as well. So the two shaded triangles are congruent to each other, right?
Yep.
This implies this part is identical to this part, right? The
Yes.
line segment noted with green. It's the same, right? So this way, this has to be a midpoint, right? Because by definition, the midpoint is supposed to be the point that cuts the line in half, right?
Oh yeah. Okay, I understand now.
Here's the first way. Okay. Now I want you guys to prove it through Pythagoras theorem.
The what?
But isn't it basically? Wait, can you zoom in a bit?
Alright.
isn't it since like x is equivalent to x and y is equivalent to y for both smaller triangles, right triangles,
Yeah.
then the last side, the third side, they will also be equivalent since Pythagorean.
This
Like-
is when the angle in between is a right triangle. Is a right angle. Is a 90-degree angle. This is why it happens.
You mean
Yeah.
like
So
a squared plus b squared equals c squared, that theorem?
Yeah, I mean, how do you prove it? Through Pythagoras theorem.
because like the top right triangle,
Yeah.
like one side is x, one side is y, and
Yeah.
then the bottom left right triangle is also one side is x and one side is y. So
Yeah.
in Pythagorean theorem, x squared plus y squared equals c squared.
Okay.
So basically, then the third side would be equivalent for both triangles.
Yes, sir. That's definitely one way to apply that. In another way, you can also do it as this, eh? You know that the total is 2y, right? The side, I mean. However, on this is 2x, right? So for the entire hypotenuse, it's 4x squared plus 4y squared, right? However, for this, for the smaller triangle, it's x squared plus y squared, right? And that's radical square root. And you take 4 out. 4. You take this out, you have 2 times x squared plus y squared. That's pretty much. So that's half. Alright?
But isn't like the second way a bit more complicated?
Yeah, it's but here's the prerequisite, right? Using Pythagoras theorem, like, cause here's the thing. Tim, for your method, it's already established on the prerequisite that we know those two triangles are already congruent. Like we know this is x, this is y, this is x, this is y. Then it's pretty much needless to use Pythagoras theorem because you have the angle in between to be the same, so it's just congruent triangle. Whereas if you haven't observed this point, Pythagoras theorem will be a brute force to solve this problem, to prove this, sort of. All right.
Oh, okay.
Okay, I guess that is the end of today's lesson. Oh, dang. I only went over one of the question. That's bad. Alright, for the question part, I want you guys to finish 9, 10, 11. Alright?
So finish 9, 10, 11, right?
Yeah,
Okay.
and show full work. Please don't just give me a garbage paper, please. Yeah, just kind of like write something on it. You don't have to write the entire solution or whatever, but just try to really show something. Let me see that you understand something. If you just write the answer and like just random stuff, even though if the answer is correct, I wouldn't know like what's going on in your mind, like how much do you understand of one problem. Yeah, pretty much. Alright, I guess that is the end of today. Thank you guys. Peace out.
Could you pin the homework, the PDF? Could you pin it? Because
Oh, sure. The homework? Well, oh, yeah. Oh, okay, sure. can I pin it in the Class A session? Like
Yeah.
the Class A chat? How do I do it? Like I'm a old man. I don't really know how to use this.
So
Okay, I see.
are you on okay. I'm not sure if you're on computer or iPad, so
I'm using computer.
I think you can just like go over, like hover your mouse over the like the
Just three
sentence.
dots, or just
Okay.
click shift.
Yeah, or you can press shift, but I don't really usually press shift. And then if you hover your hard to explain. So if you hover your mouse over the homework, you can
I'm pressing shift.
no,
Oh, can you guys see it right now?
oh yeah, okay. Yeah, you pinned it.
Okay, let's go. All right, thank you guys.
Okay, thank you. Bye.
Bye. I'll post
Thank you. Bye.